With the worldwide demand for electricity growing day by day, utilities are under increasing pressure to meet supply and maintain safety and reliability. Managing vegetation growth within the network is critical, as vegetation encroachments are one of the principal causes of power outages. Current vegetation management practice varies, consisting of foot patrols through to the use of geospatial technology to calculate exact vegetation encroachments. NM Group have been refining the use of LiDAR and other geospatial data for utility vegetation management purposes for many years. Recently, they have undertaken a Knowledge Transfer Partnership, or KTP, with academic leader Durham University to identify new utility applications and innovation. Today we're out at Kielder Water and Forest Park, which is one of the many locations where we go out into the field, take measurements of the trees, which we can bring back with us to the office to help us improve our vegetation algorithms and workflows. Some examples of the products the data collected here today will help to refine our vegetation health, vegetation risk analytics and vegetation structure. I'm really impressed with the way that NM Group are taking the time to invest in their research and development and also pair up with Durham University so that academic knowledge underpins a lot of their workflows and analytics.
High-resolution LiDAR data is one of the best remote sensing methods for identifying power line wires and structures. It allows us to create a highly accurate 3D representation of the conductors, towers and surrounding vegetation, and through further analysis provides a record of vegetation encroachments and falling hazards over large areas. These are things that help vegetation managers to better prioritise tree cutting and also to look at options to reduce costs. The KTP has helped improve our services, and the use of Durham University research ensures they are tested with scientific methods. We have spent a lot of time modelling complex clearance shapes, not just radial or linear clearance distances. This means we can match our analysis directly to a client's internal or mandated policy. In addition, we can also create a tree inventory, making a database of each tree canopy for a utility. We provide volumetric or area measurements to determine the volume of vegetation to be cut. This can be compared to previous year's data to audit field contractors. Assessing vegetation growth can be used to better plan cutting cycles and manage field resources more efficiently. We are seeing lots of demand from our clients to be able to visualise and walk through the data within a 3D environment. 3D software such as our Cadence platform allows vegetation managers to visualise their network, so they more effectively plan and reduce the number of trips to the field. 3D data is going to increase efficiency and identify new ways of reducing costs.
In the Geography department at Durham University, we have been undertaking research in the use of remote sensing for forest resource mapping using satellite imagery for more than 20 years. Mapping environmental resources such as forestry with airborne laser scanning, or LiDAR, became possible in the late 1990s when satellite GPS could locate the position of laser pulses from aircraft and helicopters very precisely. Our work has focused on the analysis of laser return pulses from different parts of the tree canopy and from the ground in order to make precise measurements of tree structure, including height and canopy shape, and in some circumstances, species and height diversity. These measurements are ideal for characterising the vegetation that surrounds critical infrastructure, such as overhead electricity transmission and distribution lines. As well as transferring knowledge to NM Group, we're able to use well-established statistical techniques to evaluate the precision and quality of the risk estimates in a range of geographical settings. Statistical validation of measurements provided NM Group's clients with a high level of confidence in their products.
Durham's partnership with NM Group has produced the knowledge, confidence and methodological rigour needed to develop tools to lead a transformation in the management of vegetation risk in power line corridors. By winning contracts in the US, Canada, New Zealand and Australia, vegetation management has become central to NM Group's growth and success. The overall impact of the KTP has been to develop high-quality, validated products that help utility companies to comply with national regulations and benefits customers by minimising the risks of power cuts caused by vegetation damage to power lines.
In the Geography department, we have just completed our second KTP with NM Group. The first project developed a web-based risk assessment tool for electrical transmission networks, and the second focused on vegetation risk to power lines. In both cases, the KTP associates were employed by NM Group and now occupy roles that did not exist before the KTPs began. Earlier this year, our project was graded as outstanding by Innovate UK. and I've been impressed by the way that the company have embraced the KTP model, where associates provide a very dynamic bridge between the university and the business. Durham has completed over 100 KTP projects, and the success of these projects is having a tangible impact on jobs and the UK economy.